Myostatin and protein synthesis would be controlled directly by the estrogen receptor.
You have mechanical transduction that is only from exercise. Then through steroids, you have P13K, you have which is like mTOR, you have the androgen receptor, and you have IGF-1 receptor. Training alone that only causes muscle growth is mechanical transduction. The three pathways from steroids are slightly different, but that's a whole different conversation.
In the past, I've talked about compounds that are collectively known as ectosteroids. These compounds have been reputed to offer anabolic properties. The ectosteroids do not interact with androgen receptors in the body. All steroids, whether it's testosterone, anabolic steroids, any of them, they work by interacting with androgen receptors. So why would they offer any anabolic effects at all?
So there's several rate limits in muscle growth in humans, but the ultimate rate limit is how many stem cells you have. Can you take a nuclei from a stem cell and apply it to the muscle fiber? So that's why things like growth hormone work as we age, because you run out of stem cells. You have three other mechanisms through steroids, or hormones, we could say.
Correct. Yeah.
So you have mechanical transduction that is only from exercise. Then through steroids, you have P13K, you have which is like mTOR, you have the androgen receptor, and you have IGF-1 receptor.
We're inducing those stem cells to come online and, go through the process of myogenesis. Some of that is stimulated through things that do affect the androgen receptor, but some of that is stimulated through an entirely separate pathway. That's my premise of this video, and I believe that pathway is what you could call the IGF-1 pathway. And it's not just IGF-1 that affects it, it's other growth factors and also changes in growth limiting factors like myostatin. As an example, anabolic steroids in livestock production, background, and implications for instance, although considered less active in cattle or sheep than in humans due to a lower concentration of androgen receptors in the muscle, these steroids are widely used as anabolic in production animals. Cattle and sheep have fewer androgen receptors than we do. So, yet the androgen receptor pathway drugs still work with them, and why is that? Chronic exposure to anabolic steroids induces the muscle expression of oxytocin and a more than 50-fold increase in circulating oxytocin in cattle. Now, I've gone on and on about oxytocin before, but this is talking also about IGF-1, estrogen, and how all of this was done. So basically what they did in this study was they gave cattle 200 milligrams of trenbolone and 20 milligrams of estradiol. What they found, the expression of IGF-1 and genes related to the extracellular matrix, slow twitch fibers, and cell cycle, including SOX8, a satellite cell marker, was increased in the treated muscle. A reinvestigation of in vivo, in real life, cattle in the same muscle samples during an early to mid-fetal development identified a greater than 128-fold increase in the expression of oxytocin, coincident with myofiber differentiation and fusion. So in other words, coinciding with myogenesis, hyperplasia, the process that is the holy grail of bodybuilding. They also found in the same study, I believe, a 1.4 to 1.9-fold increase in IGF-1. There was movement along that similar pathway, but what this does show is that the IGF-1 pathway, the oxytocin pathway, which oxytocin actually stimulates follicle stimulating growth factor and all these other growth factors that you might not have, that I didn't hear about until I started studying it. Number one, cattle have fewer androgen receptors as far as overall density than humans, and yet they still grow very well from trenbolone and estradiol. Why is this? Well, it's not just the androgen receptor that's driving the muscle growth. That's my point. The androgen receptor, as Jerry Brainum was saying, is not affected by ectosteroids. But that isn't the only growth pathway. And I think that the IGF-1 pathway, as kind of a shorthand for this entire growth factor mediated myogenic promoting pathway, is vastly understudied, vastly misunderstood. It's used just unknowingly by modern bodybuilders using certain peptides, growth hormone, and certain strategies. When a person has basically maxed out their response to traditional androgens like testosterone and DECA and that sort of thing, the first thing they'll often do is get on growth hormone. And then because growth hormone tends to lower insulin sensitivity somewhat, or a lot, depending on the person, they get on insulin. And they think, well, I've actually heard that if you use growth hormone, insulin, and testosterone together, you'll get a synergistic effect. Is this true? Yes, absolutely, it's true. Even 15, 20 years ago, when I was fooling around with full cycles of stuff, when I would add in growth hormone, I would hold more water weight. So yes, there was more bulk gained. But when I added in insulin on top of that, even short-acting insulin on workout days, pre-workout with carb loads and stuff like that, it was more than just fluff. I would gain another 7, 8, 9 pounds on cycle, and out of that 7 or 8 or 9 pounds, 2 or 3 of that would be extra muscle that I wouldn't have seen otherwise. It's due to insulin's downstream effects. It's due to growth hormone's downstream effects. Growth hormone turns into and stimulates the production of IGF-1. Insulin actually does something similar. I believe that insulin, and I don't have something to back this up necessarily at the moment, but I believe that insulin is a signaler, an opening, like a, hey, go ahead and pass go here, to open up that IGF-1 process of myogenesis and the integration of those new baby muscle satellite cells to grow and become and experience hypertrophy at the final stages and put on that size. And I think that's where those 2 or 3 extra real pounds of muscle are coming from. We all know that adding growth hormone and insulin, you're going to get bigger than you would without. And we know that growth hormone on its own doesn't do jack shit, really, except for add a few pounds of water. We know that insulin on its own doesn't do a whole lot except for add a few pounds of water and fat and carbs, right? So the combination, androgens, growth hormone, insulin. Now that's kind of the sledgehammer approach. That's all the basics. It's like driving a bulldozer and saying, let's grow. From this study here, we can see that oxytocin was a very strong driver of muscle growth and anabolism, myogenesis, etc. in cattle. And over on this study here, oxytocin precursor gene expression in bovine skeletal muscle is regulated by 17 beta estradiol. So estradiol, that's the reason that was so successful in that study that we just looked at before with the cattle, is that they gave them trenbolone and a decent portion of estradiol to open up that IGF-1 process, etc., right? Now, this is an interesting study that I've referred to a few times, and one of the things I like about it the best is how simply they broke down the way that they think that ecdysterone in particular is acting in the body, the actual pathway that it takes. In this diagram right here, we can see 20E, that's their abbreviation, 20-hydroxyecdysone, which is ecdysterone. And they're indicating, hey, this works on the MAS receptor, which raises nitric oxide synthesis. Now that's why when we take good strong ecdysterone or a plant sterile complex, that's why we get a pump within a few minutes. Then downstream, it acts on the estrogen receptor, which lowers myostatin and raises protein synthesis. Now this is completely oversimplified, obviously, but this is straight out of the study. Figure number 5, proposed mechanism of myostatin gene control by angiotensin 1 through 7, 20E, and E2, which is estradiol. According with this scheme, myostatin and protein synthesis would be controlled directly by the estrogen receptor and indirectly by the MAS receptor, while nitric oxide synthesis would be controlled directly by angiotensin 1 through 7, or 20E, and indirectly by E2. So this is very plain. I believe they have a pretty good basis for making this claim in this study. What essentially they're saying here is the estrogen receptor is actually a mediator for a lot of the growth process that happens. And I believe this is the overlooked pathway. You could call it the estrogen receptor pathway, interestingly enough. I'm calling it the IGF-1 pathway just because people know what IGF-1 is supposed to do. It's supposed to develop that new muscle tissue and, bring hypertrophy to those immature satellite cells. And this is essentially what this is indicating: a lowering of myostatin, which opens the gate, a raising of protein synthesis, which could be mTOR essentially. But we also know through these other studies, oxytocin is regulated by the estradiol receptor. We know that there was a 97-fold higher expression of oxytocin when they gave them trenbolone and estradiol. So we know that that is part of that growth pathway. Many of these different things will actually open and stimulate this pathway. This is the kind of results I see when I take a slow release oxytocin. That's an injection that lasts 24 hours in the body. That slow drip is constantly turning on that growth pathway. If you take a peptide and it lasts 6 or 8 minutes in your system, whoop-de-doo, you've stimulated protein synthesis for all of 8 minutes, right? Who cares? But if you have that for 24 hours, a slow drip of that, that's when you really start to see growth and results. To be frank, I essentially stumbled across the growth potential of oxytocin itself. Now, when I say stumbled across, I mean someone else brought it to my attention, and I'm very grateful for that. Thank you. You know who you are. And as I began to study that, someone else brought me another study, in fact, that study on cattle and oxytocin. And while all that was going on, I just happened to be researching the reason why bodybuilders were reporting a huge amount of results from Increlex, which is native IGF-1 in a special solution, versus IGF-1 LR3 and all these other forms of it. Well, I had just found the Increlex label, and I found out, hey, man, this has, polysorbate 20, and it has glacial acetic acid and these different things that all together with the salts and the various things in it leads to the purported 5.8 hour half-life that you have with Increlex versus the 2 to 8 minute half-life that you have with native 70 amino acid IGF-1. LR3 lasts for a long time, but I've talked about that before. It can last a long time, but if it's not getting into and activating the IGF-1 receptor, then what's the point? I began to put 2 and 2 together, and I realized that in this cattle study, they were talking about IGF-1 and oxytocin together along a similar pathway, and I've heard before how IGF-1 is actually mediated by the estrogen receptor. I noted that oxytocin and IGF-1 native, the effective IGF-1, had a very similar half-life in the body, and Increlex had extended that. I didn't have native IGF-1 at the time, but I did have oxytocin, so I made an oil-based form in castor oil. If you're doing close to 0.5 milliliter, it'll last 2 days in your system because the bolus dissolves so slowly when used subcutaneously. When I did that, this is when I made this post, February 9th, and I was 214 pounds. This picture was taken at 215. And as of March 13th, so just a month later, and I was up to 238. So the top picture, look at the size of my shoulders versus and chest and everything, and I'm just way bigger. And I was as shocked as anyone. In fact, the guy that had sent me the original study was shocked too. So, of course, he tried the same thing, and he did not put on the same amount of weight that I did. He put on about 10 pounds instead of 20, right? So everybody's a little different, and I may have been primed to grow for that from some various things I was doing before, like fasting. Once the activated and fortified stem cells that you've accrued are used up and the hypertrophy has already occurred and the muscle growth has happened, you've got no more reserves to draw on, and so you just start to store calories. Ever since then, I've been using oxytocin periodically for growth spurts, and I have come to understand my body as far as when I can make that happen and when I can't. Interestingly enough, fasting seems to, and ketogenic diets, ketone bodies, the stress of training to some extent, seems to actually help accrue and fortify some of those stem cells. Keep in mind, they're there as basically backups to stress. So stress without necessarily having the rest and feeding that we might need. So not necessarily overtraining per se, but just the stresses of life day to day to day without the big kickoff from an androgen cycle. We have some of those stem cells accrued, and then when we do an androgen cycle, we grow. So it's tied into the androgen receptor pathway, but it's its own thing in that it can be activated without an androgen receptor boost. So in other words, when I gained that 20 pounds, I didn't take extra testosterone. I didn't take any other drugs with it. It was just the oxytocin was the only thing that had changed. I got into the whole plant sterile thing originally when Vigorous Steve put out a call for somebody to be able to make a viable injectable ecdy or turkesterone. So I ordered some and I began to experiment with it. It took me about 6 months to make an ecdysterone injectable that really even was viable whatsoever, and it was still pretty rough. So a few things dawned on me, and I realized that I could complex it and then have a water-soluble injectable that was much more concentrated, much more smooth, and easier to inject and stayed in solution better, and all these sorts of things. That was a huge breakthrough. This is where it gets stupid. So after that, I go all through this oxytocin thing after extending the half-life of it, and not once did it really occur to me to try to do the same thing with ecdysterone. So I thought, why don't I make a hydrogel of this? So I put it all together, made a hydrogel, just as a lark, just to send to this one buddy, to be honest. So if you're out there and you're listening, man, you know who you are. Some of these things can get pretty concentrated and there's lots of pip. And I took that test shot of that long-release ecdysterone, and over the next 3 days, I gained like 3 pounds. Now, some of that's obviously some kind of mineral retention or something, but it was the first time since my fast that I was able to actually add any kind of weight at all. And then I noted the neurological effects were very similar to my oxytocin. And what I mean by that is when I use that strong, slow-release oxytocin, I have increased concentration, increased processing speed, better creativity, a little more, I'd just say aggression, but more oomph. And, you can feel it essentially. And this was right at half of what the oxytocin would be experienced as. I think what's going on is the 20E, the beta-ecdysterone, the sterile mix, is working along the same receptor through the estrogen receptor and stimulating a lot of those same processes. And so I went ahead and extended the run. In fact, I extended it. I added genistein to the mix and DHEA, and all together, over the course of, I believe I ran that about 10 days, I put on about 6-7 pounds. I can see it in the mirror. You can feel the tightness when you start to grow. I thought, man, this is familiar, and it's right at about half as potent as what the oxytocin affects me at. So very interesting. I'm just happy to report that there's a natural thing that seems to stimulate growth along that same pathway.